Hey, calculus fans! Today we're learning about how to solve limits algebraically. Here's the basic strategy for solving algebraic limits. Plug in the x value to the function. If you get a numerical value, you're done. But if you get an indeterminate form, you have to do some algebra. Remember that two common indeterminate forms in calculus are 0 over 0 and infinity over infinity. Here's our first example. The limit as x approaches 2 of x squared plus 2x plus 1. The first thing we're going to do is plug in 2 to this function and see what happens. And when we do that, we get 9. That means the limit is 9, and we're done. For all continuous functions, it's this simple. We would just plug in the value and find the limit. Issues arise when we're trying to find the limit at a discontinuity. Here's another example. The limit as x goes to 3 of x squared minus 4 over x minus 1. When we plug in 3, we get 5 over 2. So we're done. Let's move on to example 3. The limit as x goes to 2 of x squared minus 4 over x minus 2. When we plug in 2 to this function, we get 0 over 0, which means we're dealing with an indeterminate form. So one technique to try when you get an indeterminate form is factoring. Here we can factor the numerator to x minus 2 and x plus 2. Then you can see the x minus 2's cancel out. Now we can plug in 2 and get our solution. The limit equals 4. Let's take a look at what's going on here. Suppose we have the function f of x equals x minus 2 times x plus 2 over x minus 2. We can obviously cancel out the x minus 2's, and that will leave a hole in the graph at x equals 2. Now we can see that the graph approaches a height of 4 as x approaches 2. Okay, here's a slightly trickier example. We have the limit as x goes to 1 of the square root of x plus 15 minus 4 over x minus 1. When we plug in 1 to this function, we get 0 over 0, which means we have more work to do. Well, in looking at this, there's no way we can factor. So what we're going to do is a trick. We're going to multiply the numerator and denominator by the conjugate of the numerator. Recall that the conjugate of a plus b is a minus b, and vice versa. In this case, our a is the square root of x plus 15, and b is 4. So the conjugate of radical x plus 15 minus 4 is radical x plus 15 plus 4. And you can see that the square root of x plus 15 plus 4 divided by the square root of x plus 15 plus 4 is really just the number 1 in disguise. So all we're doing is just transforming the equation by multiplying by the number 1. Now let's go back to our algebra and remember that a plus b times a minus b is actually a squared minus b squared. We can apply this pattern to our new numerator. We have a minus b times a plus b. So the numerator can now simplify to the square root of x plus 15 squared minus 4 squared. Now if we get rid of the exponents, we get x plus 15 minus 16, which is x minus 1. So now our numerator is just x minus 1. And you can see that we can cross that factor out with the x minus 1 in the denominator. That leaves us with the limit as x goes to 1 of 1 over the square root of x plus 15 plus 4. Now we can try to plug in 1 again, and when we do that, we get 1/8. That means we're done. Let's look at one more tricky example. Suppose we have the limit shown here, where we have complex fractions, meaning fractions within fractions. If I plug in 0 to this equation, we're going to get 0 over 0, which is again an indeterminate form. That means we have more work to do. There's no way to factor here, and since we don't have a radical, there's no need to use a conjugate. So what we're going to do is we're going to combine the fractions in the numerator and see if we can go from there. So let's combine these fractions by first finding a least common denominator, which is 3 times x minus 3. Simplifying, we get x over 3 times x minus 3 divided by x. Let's rewrite the complex fraction as a product. We get x over 3 times x minus 3 times 1 over x. This allows us to cancel out the x's in the numerator and the denominator. And now we have the limit as x goes to 0 of 1 over 3 times x minus 3. We can plug in 0 now, and that's going to give us negative 1/9. And now we're done. So let's recap. The first thing you should do with an algebraic limit is plug in x and see if you get a numerical value. If you get a numerical value, you're done. If you get an indeterminate form, you need to do some algebra. And that's how you rock calculus.